Welcome, Pre-Algebra class, to the next lesson. I hope you're ready for a fun lesson. Yay. Right now, Alex is trying not to laugh because she's in the room while I'm filming. Hopefully she won't bust up laughing and start giggling. That'd be embarrassing for all your friends to hear you laughing right now. So she's turning red. This is impressive. All right, back to the lesson. 8.1. This is the first section from chapter 8. This is talking about relationships and functions. And what we'll be taking a look at right now is mostly some sentences and words that you're going to have to write down. So I don't know what would be best for you to pause the video and write it all down and then go back and listen to it, or if you can listen and write at the same time. But you need to make sure that you're writing the words down and you're really listening and taking in what I'm saying so you can best understand this. So let's go ahead and get started. And remember, pause it at any time if I move too fast. So first, we got our definition here. A relationship. So the word we're defining is relation. A relation is a set of ordered pairs. So a relation is a set of ordered pairs. And based on this definition, we're going to need some other things described to us. What's an ordered pair? What does it mean by a set? So we're going to take a look at that. So here you have, let's talk about ordered pairs. Ordered pairs are written like this. I think it's better just to show you what it looks like, then tell you what it means. But an ordered pair is typically written like this. I color-coded it to make it easier. But to be an ordered pair, it has to have parentheses, and it's going to have usually some number here, comma, and then a second number. So it's got two numbers. An ordered pair, pair meaning two, is like this. You've got your parenthesis, X number, comma, Y number, close parenthesis. That's how it's written. Now let's see if we can understand a little bit more about what an ordered pair is. So here we have another ordered pair, and these two things in here, they're called coordinates. They're typically written with numbers, and that's when we're able to use them really easily, like coordinates on a map or a grid to know your location. And we're going to use it using something called the coordinate plane. We're going to do some graphing later. But for right now, just know that these two things are called coordinates. So if I ask you what are the coordinates and we were using numbers, you could say something like, oh, the coordinates, I'm starting at point 5,9. And that tells me that you're at point 5,9. The first coordinate, the x coordinate, it's known as the domain, while the second coordinate is called the range. And this is important because this is especially once you get to Algebra 1 and Algebra 2, these things are used a lot in there, functions and all that. So in the ordered pair, 5, -8, 5 is the domain, -8 is the range, all right? So we did that. So a relation is a set of ordered pairs, basically like a group. It would be like if I had a bunch of things like this, and we'll see an example in just a minute of what a relation is. Last thing to do is to define a function. Sorry. This has it is, is, that's supposed to be is. So a relation is a function if each of its members of the domain is paired with exactly one member of the range. So something is considered a function. A relation is considered a function if each member of the domain is paired with exactly one member of the range. So what does this mean? We'll take a look. Like I said, you might not understand this right away, but once we look at some examples, I think it'll click. Just remember that the domain is the first number, while range is the second number. Is each relation a function? So this is a relation. It's a set of ordered pairs, like if you have a set of action figures or a set of CDs. It means that you got more than one usually. So this is a set of ordered pair. That's an ordered pair, that's an ordered pair, that's an ordered pair, so we got a set. Is it a function? Well, the definition said that each member of the range is paired with exactly one member of the range. And the easiest way to tell if it's a function, when you're given a list of numbers, they might give it to you like this. They might use like a table chart, and they'll say, well, the first column is all of the x values. The second column is all of the y values. Here's the easiest thing to do. If there is more than one of the same number in the first spot, meaning these spots, okay? Okay, these spots. If there is a duplicate number there, and it's paired with a different number than its other duplicate, it's not a function. Are there any duplicates here? We have a 0, 3, 4, and 5. There's no duplicates. This makes it yes, it is a function. As you come down here and you take a look at this one, we look at the first numbers. I'm just putting a little circle here to help it stand out. You don't have to do this, it has no purpose. But we look here, we have a 1, 3, 1, and 4. Whoops, those two repeat, 1 repeats. Now look at the second number. If the second number is different for each of those, then it's not a function. Yep, definitely not a function. So this is not a function. All right. So we could say not a function. And in class, we're going to take a look at what this more means using graphs. And we're also going to go over something called the vertical line test. Remember to ask me about the vertical line test in class, and it's a really simple way to check to see if a graph is a function or not. All right. Now let's get on to the more math-involved part of this. This is equations with two variables. And we're typically going to be looking at functions. These are relationships that are functions. And we're going to learn how they can be used for figuring out data, for predicting things that might happen later on in the future with numbers, and how to graph them so we can make those predictions more accurately. So we're told to find the solution of y equals 3x plus 2 for x is equal to 5. So this is what we're doing. Even though there's two variables here, we're going to end up replacing one of the variables with a number. This puts us in a position where we just have one variable. And with the ones we're going to start off with working, y is going to be the variable we're looking for, while we're going to be given what the x value is. And it's usually going to be written in this y equals form. If it's like this, our work is actually really easy. Let me show you. You're just going to plug in. So you're going to say y is equal to 3 times 5, close parenthesis, plus 2. Follow your order of operations. We're not solving equations now, technically. We're just working it out. So now we could get y is equal to 15 plus 2. So y is equal to 17. Now this is not our final answer. Our final answer is actually this. It is 5, 17 as an ordered pair. So make sure you put them inside parentheses and put a comma between them. You have to do that for it to be an ordered pair. That's your actual answer. The reason why, because when you're finding a solution for an equation like this, the solution is an ordered pair. That's how you write the answer. Like before, how you were required to write x equals 5 if that was the answer. Now when we have two variables, we need to write it like this. And by the way, the x, as I said in the previous section, needs to fill in the first spot, while the y goes in the second spot. Might want to remind yourself that. Maybe get a colored pen or pencil out and write down x under here and y under there, so you know that the x has to go in the first spot, the y has to go in the second spot. It's actually very important as we go through this. All right, here's another example. Find the solution of y equals negative 2x plus 5 for x is equal to 7. So we've plug this in. Y is equal to negative 2 times 7 plus 5. So we could multiply next. Y is equal to negative 14 plus 5. So y is equal to negative 9. Oops, sorry about that. So we multiplied this to get our negative 14. We added the negative 14 to the positive 5 to get negative 9. So y equals negative 9. That's not our answer. Don't box that in. Instead, come over here and put down 7, comma, negative 9, like the parentheses. And last, let me just go over this. Graphing will be shown in class, but you need to know that X tells the horizontal, meaning side to side direction, and Y tells the vertical direction, meaning up and down. So, as I said, we'll cover the graphing in class. See you then. Bye-bye.